Okay, grade 12, we are continuing with mathematics paper 1, pre-June maths exam. So we are now at question 8. On question 8, I'm very sorry, guys. I'm not going to do 8.1, which is deriving a function from the first principle. But I believe that you can be able to do this one. 8.1, deriving a function from the first principle. The derivative of a first principle is always there. So most likely, I believe that you can be able to work it out. I want to start with 8.2.1. Okay, so they are saying determine dy over dx if xy equals to 3. This is where our grade 12 student can lose free 2 marks. This is a free 2 marks. Determine dy over dx if xy equals to 3. So they want us to derive a function y with respect to x. Now, before we even derive, it's very important to make sure that y is the subject of the formula. So you have to make y the subject of the formula. So you divide both sides by x so that y guy can be alone. Y equals to 3 over x. Now, because y is the subject of the formula, it should be easy to derive the function y with respect to x. But before you even derive, make sure that the variable x is not the denominator. So I'm going to take the variable x to the top. This x, I'm going to write it on top. So it's going to become 3x to the exponent -1. Remember, it was x to the exponent 1. So when it comes to the top, the sign of the exponent, they change. Now it's x to the exponent -1. Now it's easy to derive. You say dy over dx. Just in case you forgot how to derive. When you derive, you take your exponent, in this case it's -1, you multiply it with the coefficient of x, with a number before x, which is 3. So you say -1 times 3, -3. You must keep your variable x. So you keep your variable x. Last step is to subtract your exponent by 1. So your exponent is -1. If you subtract 1 from -1, you have -2. So dy over dx equals to -3, x to the exponent -2. This is your derivative. Dy over dx is equals to -3, x to the exponent -2. You can also write your exponent in a positive form. You can say dy over dx equals to -3 over x squared. Okay, that was 8.2.1. So I want us to find the derivative with respect to x on 8.2.3. 8.2.3. Okay. Firstly, what I'm going to do on 8.2.3, I'm going to say I cannot rush into deriving as long as I have the root. So I have to remove the root first. So I'm going to say this is x squared raised to the exponent 1 over 3. Remember, that was a cube root. So you raise x squared to the exponent 1 over 3. Then you say minus 2x plus 1 all over x squared Now I'm going to apply this rule, which comes when we add the fractions. If I have A over B plus C over B plus D over B, this is the same as A plus C plus D all over B. This is how you add fractions. As long as you have got the same denominator, in this case, our denominator is B. A over B plus C over B plus D over B. What you can do, you can add the numerators and you keep your denominator. So you say A plus C plus D all over B. So you see that A plus C plus D all over B can be written as A over B plus C over B plus D over B. So this is what I'm going to do here on this problem. I'm going to say this is the same as x to the exponent 2 over 3 divided by x squared plus or minus, so it was minus 2x. So it's minus 2x all over x squared plus 1 all over x squared. So every term is divided by this x squared. So we divide this guy by x squared. We divide this guy by x squared. We divide this guy by x squared. All these terms of the numerator were sharing this x squared. Now, what is x to the exponent 2 over 3 divided by x squared? Here we apply law of exponent. The base are the same. If you divide powers of the same base, you keep your base, you subtract your exponent. So you're going to say 2 over 3 minus 2 minus 2. Even here you say x to the exponent to 1 minus 2. The base is the same. You subtract the exponent. The exponent here is 1. 1 minus 2 plus 1 over x squared. Just take this x to the exponent 2, bring it to the top. It becomes x to the exponent negative 2. So I have something like this. I have x to the exponent 2 over 3 minus 2. So I have to figure out what is x to the exponent 2 over 3 minus 2. Okay, 2 over 3 minus 2. How much is 2 over 3 minus 2? I don't have a calculator, but I know that 2 is 6 over 3. And 2 minus 6 is negative 4 over 3. So please confirm it. This is going to be x to the exponent negative 4 over 3 minus 2 x to the exponent negative 1. 1 minus 2 is minus 1 plus x to the exponent negative 2. Now I can derive. Now I'm deriving. When I derive, I'm going to say this is minus 4 over 3. Keep my variable x. I'm deriving the first term. Minus 4 over 3 minus 1. How much is minus 4 over 3 minus 1? I believe it's minus 7 over 3. Then if we derive the second term, minus 2, x to the exponent negative 1 is going to be positive 2 x to the exponent negative 2. Hopefully you recall how we derive. We take the exponent negative 1, we multiply it with a number before x. Negative 1 times negative 2 it gives you positive 2. You keep your variable x. Do not forget to subtract the last thing when you derive. You subtract your exponent by 1. -1 minus 1 becomes -2. So if you derive the last term, x to the exponent -2 is -2x to the exponent -3. This is our final answer on 8.2.3. You can decide to write it in such a way that the exponent are positive. If you write it this way, it's still acceptable. If you say -4 3x to the exponent 7/3 plus 2x/2 minus 2x/3. That will still be acceptable. So now we can go to question 9. We can now go to question 9. Okay, the graph of f of x equals to -x cubed plus 3x squared plus 9x minus 27. So here we are dealing with a cubic function. We can see that it has also been sketched. I'm going to represent my cubic function with a blue color. I have this function. It's a cubic function. Okay, and g of x is equals to tx plus q. This g of x, it's our straight line on the graph. You can say they wrote g here. So they are saying this is my g of x. It's a straight line of the graph. I'm representing it with a red color. That is my g of x, which passes at the point E and also passes at the point B. It also passes at M, the straight line. Okay, A and B are the x-intercept. A and B are the x-intercept, and C the y-intercept of f. Yes, A and B, these are the x-intercept of a function f, a cubic function, because the cubic graph cuts the x-axis at B and also at A. Okay, C is the y-intercept. Yes, C is the y-intercept of f because the f cuts the y-axis at C. The turning points of f are D, which is -1 and -32. So they gave us the turning points of f. This cubic has got the turning point. So D is -1 and -32. And B is also the turning point, but they did not give me the coordinates of B, the turning point of F. G and F intersect at E. Okay, E here is the point of intersection, which is -2 and -10. Okay, so what is the first question? Show that the equation of G is y equals to 2x minus 6. Show that the equation of G is y equals to 2x minus 6, and they are promising us 4 marks if we find the equation of G, which is a straight line. So G is our straight line. G is our straight line. So we are looking for the equation of a straight line. Equation of a straight line. And guys, we know that to find the equation of a straight line, we need the gradient of that line. We must have the gradient of the line, and we must also have at least 1 point on that line. We need the gradient and 1 point on the line to find the equation of the line. So we are looking for the equation of G. We must have 1 point and the gradient. Now, we see that the line G passes at E, and we have been given the coordinates of E. We are told that E is minus 2 and minus 10. At least we have got 1 point on the line. So we will need to find the gradient. Okay, so, and to find the gradient of a line, we can use the formula which says m equals to y2 minus y1 over x2 minus x1. I normally call this the average gradient. The average gradient. So, okay, you can see that we've got y2, y1, x2, x1. So we need to have, in order to use this formula of an average gradient, we must know 2 points. So we have point E. We know the coordinates of a point E. It's minus 2 and minus 10. It will be a good thing if we can have the coordinates of the point B, so that we can use the formula y2 minus y1 over x2 minus x1 to find the gradient of a line passing through the point E and the point B. Or one maybe can say M equals to YB minus YE over XB minus XE. Instead of saying y2 minus y1, you can say y at B minus y at E over x at B minus x at E. So we need to know the coordinates of B. We have the coordinates of E. If we can know the coordinates of B, it will be easy to find the gradient of a line EB. So how can we know the coordinates of B? We know that B is the turning point of F. B is the turning point of the function F, which means that we can find this coordinates of B using the fact that B is the turning point of F. Okay, and I love this problem. I'm going to find the coordinates of B by taking into account that B is the turning point of F. How do we find the turning point of a cubic function? Through first derivative. Through first derivative. If you are looking for the coordinates of B, which is the turning point, to find the turning point of a cubic function, you can do that by using the first derivative. So I have f of x equals to minus x cubed plus 3x squared plus 9x minus 27. Now I know that if I can do what we call the first derivative, f prime x, my first derivative, I should be able to find the coordinates of the turning point. This is how we find the coordinates of the turning point, through the first derivative. So you derive your function. The derivative of negative x cubed is negative 3x squared. Just in case you forgot how to derive, I will keep reminding you. The number before x cubed actually is negative 1. So when you derive, you take the exponent, you multiply with a number before x, which is negative 1. So you say 3 times negative 1 is negative 3. You keep x. What is the last thing that you do? You subtract your exponent by 1. The exponent here is 3. If you subtract it by 1, you now have 2. So let's keep deriving. What is the derivative of 3x squared? Follow the same procedure. It's going to be 6x. What is the derivative of 9x? It's a 9. What is the derivative of negative 27? 27, it's a constant number. Its derivative is 0. So we've got f prime x equals to minus 3x squared plus 6x plus 9. Now what you do, you put this f prime x 0 because we know that at the turning point, the gradient is 0. Actually, this f prime x denote the gradient. It represents the gradient. And at the turning point, the gradient is 0. So you put f prime x 0. You say 0 equals to minus 3x squared plus 6x plus 9. So 0 equals to, I'm going to divide every term by negative 3, just because negative 3 is able to go into each and every term here. Let me say every term is divisible by negative 3. So if we divide negative 3x squared by negative 3, we are left with x squared. If we divide 6x with negative 3, we are left with negative 2x. If we divide 9 with negative 3, we are left with negative 3. So 0 equals to x squared minus 2x minus 3. Now what you can do, you say 0 equals to, you factorize x, the factors is 3 and 1. We know that the big number most of the time takes the sign of a middle term. So I'm going to put it negative. I'm going to put it positive. So x equals to 3 or x equals to negative 1. So these are the coordinates of the turning point. So the negative 1 obviously will go to D. This is where x is negative. And then 3 will go to B. So the x turning point, the x coordinate of the turning point at B, it's 3. So I will say I know that the x coordinate at B is 3. And because B is also, it is not only the turning point, guys, it is also the x-intercept. It means that the y coordinate at B is 0. Actually, you had many ways of finding the coordinates of B, but I think using the idea of the derivative, it's more simpler. So because B is the x-intercept and it's also the turning point. So that is why I'm saying there are two ways you could have approached the idea of finding the coordinates of B. You can find it through the first derivative because B is the turning point. So we notice that the x turning point is 3 and negative 1. So obviously at B, x has to be positive. So the x turning point of B is 3 and the y coordinate of B is 0 because B is the x-intercept and the y coordinate of the x-intercept is 0. So now I have the point E, which is negative 2 and 10. And I have the point B, which is 3 and 0. So it's easy now to find the gradient of a line passing through the point E and B. So you say y2 minus y1. Let me take 0 to be my y2. 0 minus, let me take negative 10 to be my y1. So 0 minus 10 over, let me take 3 to be my x2. 3 minus, let me take negative 2 to be my x1 minus 2. So I have got 10 over 5, which is 2. So the gradient of a line EB, it is 2. Now it should be easy to find the equation of this line EB. Y equals to mx plus c. What is my y? Use any point. I'm going to focus on point B. On B, y is 0. M, my gradient is 2. My x at B, it's 3 plus c. Therefore, c equals to negative 6. 2 times 3 is 6. If you take it this side, it's negative. So y equals to 2x minus 6. You can write it as g of x equals to 2x minus 6, which is the equation of the line EB, the equation of a straight line which passed through the point E and passed through the point B. It's very important. If you are looking for the equation of a line, you need to find the gradient of that line. So how did we find the gradient of a line? We use the formula change in y, change in x, y2 minus y1 over x2 minus x1. Okay, now for what values of x is f increasing? Okay, for what values of x is f increasing? I love this question. For what values of x is f increasing? So whenever you study your function, observe it from the left. So I'm going to observe f from the left. Okay, let me use the red color, and then I am moving on the f. So if I'm moving from the left downwards, it means the function f is decreasing. So the function f is decreasing up until the turning point. So here f is decreasing. Now, from the turning point, when you observe the graph, it starts to increase. Okay, this is where the function is increasing up to the point B. So it's actually from the point D to the point B where the function is increasing. Okay, I'm saying, guys, study your graph from the left to know whether it's increasing or decreasing. Study it from the left. So if you observe it from the left, from this point of the left, it's going down, it's decreasing. When it reaches the point D, we say the function is stationary. Remember, D is called the stationary point. Exactly at the point D is not decreasing and it's also not increasing. Exactly at D, we say the function is stationary. Now from there, when it starts going up, that's when we say it's increasing. So exactly at the point B, we say the function is stationary. So between the D and the B point, that's where the function is increasing. Because this side, if you observe it, it's going down, it means it's decreasing. Kana, what are the coordinates of D? We are told that the coordinates of D is a -1 and -32. And we just found the coordinates of B to be 3 and 0. So between D and B, between -1 and 3, this is where the function f is increasing. You write it like this. -1 and 3. Do not write it this way. Do not say -1 is less than equals to x is less than equals to 3. This should be wrong. because at -1 and at 3, the function is stationary. So you write it this way. You say the function is increasing on the interval where the values of x are between -1 and 3. Now they are saying, what are the values of x whereby the derivative of f is decreasing? What are the values of x whereby the derivative of f is decreasing? Wow. Wow. So this is my function f. This is my function f. This is a cubic function f. What you guys have to know or to recall, I'm giving you this information and I will need you guys to remember it. If we look at the function f of x and its derivative, we look at the function f prime x. The function f of x is a cubic function, and its derivative is a quadratic function. And the quadratic function has what we call the x-intercepts. So what you guys need to know is that the turning point of a cubic function will be the intercept of its derivative. So if I give you f of x and I say to you, this function f of x, which is a cubic function, it tends where x is -1, and it also tends where x is free. So this x turning points will be the x-intercept of the derivative of this cubic function. If you derive a cubic function, what you get is a quadratic function. And the turning points of this cubic function will be the x-intercepts on a quadratic function. So let me say it will, the -1, this -1 here will become the x-intercepts of a quadratic function. This x equals to 3, this turning point will become the x-intercept of a quadratic function. So the turning point of a cubic becomes the intercepts of its derivative, which is a quadratic function. Remember, a quadratic function must have the x-intercepts. And we are saying if you have a function which is cubic, when you derive cubic function, you get a quadratic function. And the intercept of that quadratic function will be the turning points of the original cubic function. So I take the turning point of this cubic function. I know that they are my intercept on a quadratic graph. So I wonder the shape of my quadratic graph. So I wonder if the shape is going to be smiling. I'm confused if the shape is going to be something like this, or if the shape is going to be a set shape. It's going to be something like this. But I know the intercepts is -1 and 3. So what is going to be the shape of my quadratic function? Now check. Let's go back to the cubic function. The cubic function is a -x cubed. I'm going to focus on the first term of a cubic function. My f of x is equals to -x cubed. And if I derive this f of x, I said to you, you are finding a quadratic function. So the first term of the quadratic function is going to be -3x squared, whereby we notice that the shape of my quadratic function is going to be a set shape, because the coefficient of x squared is less than 0. So if the coefficient of a quadratic function is less than 0, which is the coefficient of x squared of a quadratic function, if it's less than 0, it means the shape of that quadratic function, it should be a set shape. So my shape therefore goes like this. My shape goes like this. Okay, let me go back to the question. For what values of x is the derivative of f decreasing? And then I said, when you study the function, study it from the left. Remember, the derivative of f, it's this quadratic function which I've drawn with a blue color. So when you study the function, study it from the left. So let us check it from this left. We notice that it's going up. This is f prime. This is f prime x. So it's going up. It means it's increasing, it's increasing, it's increasing up until we reach the turning point where it starts to decrease. Where it starts to decrease. So they are saying, what are the values of x whereby the derivative of f is decreasing? So we have to identify the coordinates here of the turning point of this f prime x. Okay, here we have got -1, here we've got 3. The x-intercept of this f prime x is -1, and another x-intercept is 3. So which is, okay, so we need the coordinates of the turning point of f prime x. Actually, I need only the x coordinate of the turning point of f prime x. What is the turning point there? I'm going to show you another method of finding the turning point of a quadratic graph. You just add the intercepts and you divide them by 2. So this quadratic graph, which is f prime x here, its turning point is going to be -1 plus 3 divided by 2, which is -1 plus 3 is 2, 2 over 2 is 1. So the x turning point is 1. The y turning point is something I'm not interested on it. So now I see that whenever x is greater than 1, the derivative of f is decreasing. Let me look at it. The derivative of f is decreasing. Yes, whenever x is greater than 1, so from the right-hand side of 1, the derivative of f is decreasing. Yes. Okay. I think there might be a simpler approach because I'm looking at the marks. There might be a simpler approach of doing the problem. So my approach might be a bit complicated. So, but the reason I took my approach is that I want you guys to know the relationship between the cubic function and its derivative. So if I have a cubic function and it has the turning point like d, the turning point it was -1 and -32, and then another turning point is b, which is 3 and 0. So this x turning point, they are the x-intercepts. They are the x-intercepts of f prime. F prime, I'm referring to the derivative of f. So the x-intercept, I know the derivative of f will touch the x-axis at -1. It will also touch again the x-axis at 3. So the turning point are the x-intercept. Now, I also had to know the shape of this quadratic graph, whether it's going to be set or whether it's going to smile. So we notice that because f of x, the first term of f of x, it was minus x cubed. When we derive this f of x, the first term of a quadratic function is minus 3x squared, which tells me that this f prime x, its graph, it's a set shape, it's concave down. So I know the graph is going to be concave down. Now I see that this derivative of f, it's increasing. I'm starting it from the left. It's increasing. It's reached the turning point, then it starts to decrease. So it is decreasing from the turning point from here to going to this side. So I have to know the x coordinate of the turning point. And I'm saying I'm giving you another method of finding the x turning point of a quadratic graph. You just add the intercept of that quadratic graph, you divide by 2. So the quadratic graph I'm talking about here is having the x-intercept of -1 and 3. So you say -1 plus 3, you divide by 2. -1 plus 3 is 2. 2 divided by 2, it's 1. So it means the graph turns at 1. So when x is greater than 1, the function, the the derivative of a function f is decreasing. Okay. Now let's check. Let's check. X times f prime x is less than 0. Okay. What are the values of x? Whereby when we take the derivative of f and multiply it with x, we get a value which is below 0. These are tricky question, high order question. So having a picture of what they are talking about is very important. So I'm having a picture of this f prime x. I know that is a graph which goes like this. Okay. So now I know here it's -1, at B it's 3. The turning point here is 1. So they are saying, when can we take this f prime x and multiply it with x? And we get the value which is below 0. Okay, okay. Okay. I want us to look at different parts of the graph. Like, let's look at it from here. I'm representing that with a red color, from here to exactly -1. So this part, which I've represented with a red color, which is a function f prime x, it has got a negative value. Our function f prime x, it has got a negative value. How do I know? The function, I will just say the function itself, it's a negative. Why? Because it is below the x-axis. Whenever the function is below the x-axis, it means that the function value is negative. So let us think of a function as being negative. So f prime x, which is, in this case, I've represented it with a red color. I'm saying from here up to -1, the function itself is a negative. So now, let us look at this point -1. All values of x to the left-hand side of -1 are negative. So if I take negative x values, if we focus where x is below -1. So I'm saying let us look on the left side of -1. All values that are on the left of -1, they are below -1. So I'm saying let us think about those values of x which are below -1. And let us take those values of x and multiply them with f prime x. We notice that we get the answer which is greater than 0 in this case. Why? Because all values that are below -1, they are negative. And I said the function f prime x below -1 itself, it's on the left side. It is also below the x-axis, which means it's negative. So if we multiply negative with negative, we get the answer which is greater than 0. So this is not what they are looking for. And then let us observe it from here, from -1 up until to this point. The function itself, f prime x, it is positive because it is above the x-axis. As long as, whenever the function is above the x-axis, it means the function is positive. So the function there represented with a green color, my f prime x in that situation, it is positive. So I'm going to say, let us look at a function between these values of x, between -1 and 0. So remember the value of x at this point is 0. Let us look at the function between -1 and 0. We notice that the function itself, it is positive. F prime x, since it's above the x-axis, it's positive. So let us take any value of x between -1 and 0 and multiply it with f prime x. So the values of x between -1 and 0, we know that they are negative. Those values of x are negative. So I'm taking x, which is a negative value, and I'm multiplying it with the derivative of f. In this case, the f prime x is positive. Between -1 and 0, the function is above the x-axis, which is positive. So negative times positive gives me negative, so which means gives me the value which is below 0, which implies that for me to take x and multiply it with f prime x and get the value which is below 0, my x values have to be between -1 and 0. So this is one of my solution, -1 and 0. Okay, and then what about this part? I'm going to represent it with a blue color. This part, the function, it's always on top of the x-axis up to the point B. The function is always on top, which means the function is positive, and all values of x from this point up to the point B, they are also positive. So positive times positive gives us positive. So what about from B? This is interesting. I'm going to represent B from B with this. Yes, this is my f of x. So I know that the function, since it's below the x-axis, this function, oh yes, Since it's below the x-axis, this function is a negative. So my f prime x, it's a negative. All the time when x is greater than 3, actually, if you look at on the right side of 3, you notice that the derivative of f, it's below the x-axis. So my f prime x, it is negative. And what about the values of x on the right side of 3? They are positive. So if you take positive and multiply it with negative, you get the negative. So another solution here is when x is greater than 3. So I believe they will say 1, 2. Very tricky. These are high order questions. Make sure that you do it several times. Okay, now they're saying Mn a maximum. If M is a point on G, Mn, oh, we see, okay, let me erase everything that I've written here. M is a point on G. We see actually that M is indeed a point on G. This M is a point on the straight line G. And then, okay, N is a point between E and B. And N is a point on F. N is a point on F. We see that N is a point on F. So what is he looking for? What is he looking for? And it's also saying Mn is parallel to the y-axis. So he's always saying for what values of x is Mn a maximum? Okay. So he's talking about Mn. So he's talking about the length of Mn. So he's saying when will the length, he's saying what are the values of x such that Mn is at its maximum. I've shown you on the functions question, especially on this pre-June exam. I've shown you how to find the quantity at its maximum. The length of Mn is going to be at its maximum whenever its first derivative is equal to 0. So we can represent the coordinates of M in this way. We can say M is x and y is 2x minus 6, representing M in terms of variable x. Then we can say N, it's x because N is on F. So our y coordinate of F is going to be minus x cubed plus 3x squared. Okay, let me do this. This is M, this is N. My y coordinates at N is going to be minus x cubed plus 3x squared plus 9x minus 27. This can be tricky. M is because, say, M is on the line G. So I'm representing y as a function of G. I'm saying y is 2x minus x. Remember, G as y equals to 2x minus 6. So I'm representing M as 2x minus the y coordinates of M as 2x minus 6. And I'm representing the y coordinates of N as minus x cubed plus 3x squared plus 9x minus 27 because N is on F. So when will Mn be at its maximum? I said whenever the first derivative of our length Mn is equal to 0. So how do we find the length of Mn? Mn is a vertical line. I told you to find the length of a vertical line. You say y at M minus y at N. What is y at M? I said it's 2x minus 6 minus, what is my y at N? Minus x cubed plus 3x squared plus 9x minus 27. So this is the length of mn in terms of a variable x. So let me just say mn equals to. Now you say 2x minus 6, you multiply out with negative. So it becomes plus x cubed minus 3x squared minus 9x plus 27. And this mn, the length of mn will be at its maximum when the first derivative of mn is 0. So I'm going to say mn prime, then I derive now. I wish I had added like terms, but I will just derive 2x and say it's x. Derive minus 6, it's 0. Derive x cubed is 3x squared. Derive minus 3x squared, it's minus 6x. Derive minus 9x, it's minus 9. Derive 27, it's 0. So now you put mn prime 0. Because I said for the length mn to be at its maximum, the first derivative of mn has to be 0. So you say mn prime, it's 0. Then you say 3x squared. You know that x minus 6x, it's minus 5x. 3x squared minus 5x minus 9. Then here you solve for x. You use a quadratic formula. Please use a quadratic formula here. X equals to negative b plus or minus b squared minus 4ac over 2a. So you will have two possible values of x. So that's what they are looking for. Just use the quadratic formula because I don't think 3x squared minus 5x minus 9 can be factorized. Or it can be factorized, but it's not that easy. Okay, so I'm saying use the quadratic formula, you'll find those values of x. Okay. Now I'm going to question 10 of calculus. I was at question 9 or question 8 and question 9. Let me stop here. I will make question 10 and question 11 on a different video.